have a vision probe and then a touch trigger probe. So using the combination of this, the complex work pieces can be measured, wherein the undercuts or some such things are there in the workpiece which are not accessible by the vision probe. This advanced machine is extremely productive on most workpieces because of its high intensity LED stroboscopic image capturing technique that operates while the stage is moving. That means when the stage is moving along with the workpiece, the measurement is possible. That means we need not have to stop the table for making the measurement. Programmable ring lighting is also provided to give the flexibility in lighting direction, angle and intensity that enables achievement of maximum surface contrast for best imaging resolution and hence accuracy on the more problematic workpiece. The fixed bridge moving table design is used for the ultimate in rigidity. A programmable power turret provides control of magnification for optimal viewing. That means whether we require 10x magnification or 20x magnification, so that can be programmed. So the turret will rotate as per the program and then we can have the required magnification. In this demonstration, we can observe a coordinate measuring machine with the vision probe and a touch trigger probe. Now you can see the movements of the coordinate measuring machine, the vision probe of coordinate measuring machine. Now the touch trigger probe is inspecting a spur gear. It is inspecting the profile, tooth profile of spur gear. Now the vision probe is inspecting the tooth profile, gear tooth profile using the optical system. Finally, the software will present the measurement results on the computer monitor. Now let us study what are the capabilities of CMM software. In the advanced CMM software, it is possible to select the required resolution, that is whether accuracy requirement is up to 0.01 millimeter or 0.001 millimeter or 0.0001 millimeter, like that. The required accuracies and resolutions can be selected. Unit selection is also possible. Depending upon the requirement, we can select English system or metric system. Conversion of rectangular coordinates to polar coordinates is possible. Axis scaling is possible. Datum selection and resetting is possible. Save and recall previous datum is also possible. We can do the tolerance entry, out of tolerance computation is possible, and measurement of diameter, center distances, lengths and geometrical and form errors in prismatic components can be calculated. Online statistics for statistical information in a batch is possible. Parametric programming to minimize CNC programming time for similar parts is possible. Measurement of plane and spatial curves is possible. Data communication is possible. Digital input and output commands for process integration is available. Program for the measurement of spur gear, helical gear, bevel gear and hypoid gears is available. And then interfacing to CAD software is also possible. Now various subroutines are used for making the computations. Some of the subroutines are discussed here. Multi-point circle. That means say we have a workpiece with a hole here. By selecting minimum of 3 points, for example, point 1 here, and then a second point at this place, and then a third point at this place. So using the minimum of 3 measured points, center point and diameter of best fit circle can be calculated, and multi-point sphere using a minimum of 4 measured points. So 1 point here, second point at this place, third point at this place, and fourth point at this place. Using a minimum of 4 measured points, center point, the software can calculate what is the coordinates of this center point, and then what is the diameter of best fit sphere can be calculated. Multi-point cylinder using minimum of 5 measured points, a best axis, a point on the axis, and diameter of best fit cylinder can be calculated. That means on this cylinder we have to select 5 measured points. Then the software will calculate best axis and point on the axis, and diameter of best cylinder can be calculated. Then vertex cone angle computation is possible using 4 measured points. So on this conical feature, 4 points should be selected. Using these 4 points, software will calculate the vertex, angle, and taper of an inside or outside surface of a cone. So if you have an extended outside cone, so 4 points, 4 measuring points should be given, and software can calculate what is the coordinates of this vertex, and what is this angle, and then what is the taper that can be calculated. Multi-point line using a minimum of 2 measured points, the software determines the best fit line through the selected points. The point of intersection between the line and the major axis can also be calculated. We have this major axis here, and we have the best fit line here. So these are the 2 measured points, and this is the best fit line. And what is the angle between the major axis and the best fit line, that can be calculated using the software. And perpendicularity of 2 lines. You can see here we have one plane here and we have second plane here, and this is the line in the first plane and this is the line in the second plane. So what is the perpendicularity between these 2 planes can be calculated by the software. That means we have to give a minimum of 2 measure points on each line. 2 points here and 2 points we should give. Then the software will calculate the perpendicularity between these 2 lines or planes. Angle of intersection, a point of intersection of 2 coplanar lines. Using a minimum of 4 measured points, software determines the point of intersection. So here we should give 2 points, and on the line 2 we should give 2 points, and software will determine the point of intersection. So coordinates of point of intersection can be calculated, and the angle of intersection of 2, this angle also can be calculated. Then parallelism of 2 lines. You can see here we have line 1 and we have line 2, and using the minimum of 2 measured points on each line. So we should give we should select 2 points on line 1 and 2 points on line 2. That means total 4 points we should give. Then the software determines the angle between these two lines, then the parallelism is tan of this angle. And then multi-point plane. So we have a plane surface here. We should give minimum 3 measure points. We should select one point here, one contact point here, one second contact point here, third contact point here. That means we should move the probe and then we should make contact here, here, and third point here. Then the software will establish a best fit plane passing through these 3 given points. And then 3D alignment. So software aligns the third axis. So this is the third axis. Software aligns the third axis through a line determined by the part origin. This is the part origin and the measure point on the part surface. Parallelism of two planes. Now in this diagram you can see this is plane number 1 and this is plane number 2. We want to check whether these two planes are parallel to each other. That means we have to select one point here and another point on this plane. Similarly, 2 points on this second plane. Then software will determine a best fit line passing through these 2 points. Similarly, best fit line passing through these 2 points, and then it will calculate what is the angle between these 2 lines. In other words, the angle between these 2 planes. The software determines the angle between the 2 planes. Parallelism is tan of this angle. And then perpendicularity of a bore axis to a plane. I can see we have a workpiece here with a bore, and this is the bore surface. The software determines the angle between a bore's center line. So this is the bore's center line, established as a line between the bore's upper and lower center points. So this is the bore's upper point and this is the bore's lower center point, and it establishes an axis passing through these 2 center points. That will be the bore's axis. And what is the perpendicularity between the bore axis and the bore face? So that will be calculated by the software. What is the angle between the bore surface, face of the bore, and the center line, and perpendicularity is tan of this angle. Now let us summarize the module 12 lecture number 2. In this lecture we discussed about the probe working, how the probe works, wherein we discussed about the micro switch arrangement in the probe, or piezoelectric element, or provision of strain gauges in the probe, and then what are the different types of mechanical probes like touch type probe and scanning type probe, and how the calibration of probes and calibration of CMM is carried out. We also discussed about the stylus changing depending upon the inspection requirement, and we also discussed about the vision probes. And finally, we discussed about the CMM software, wherein we discussed about capabilities of software and what are the various subroutines used in the software. With this, we will conclude this lecture. Thank you.